Good day, everyone. Welcome to another DevToberfest Week 4 security session. This morning, we have Michelle with us to talk about container security. And really, without much further ado, I'll go ahead and turn it over to you, Michelle, to introduce yourself and jump right into the content for today's educational session.
Thank you, Thomas. It's a pleasure to be here again for another lovely DevToberfest day. I'm Michelle Chaburka, as Thomas mentioned. I'm from SuccessFactors, our people organization that makes our wonderful SuccessFactors software. And I'll be speaking today on container security. It's all about the supply chain. So who am I? Again, Michelle Chaburka. I'm a chief security architect in SuccessFactors. I'm the creator of the former Healthy Paranoia Security podcast. Yes, you can still listen to it out there. I'm a former analyst, researcher, blogger, B2B writer for things like TechTarget and UBM publications. I'm also a recovering Unix and network engineer. The software supply chain, let's just dive right in. Wait. I know what you're asking. Containers are software? Yes, they are. So let's just go over a typical software supply chain as a refresher in case people need that. So you, of course, have the product management phase where you document your working requirements and you assign your development tasks in terms of product ownership. You have your development portion of the life cycle, where you're planning features, you're writing code, you're building, you're testing. And then you have, this is really very, abstract and very high level. And then you have operations where you deploy, release, operate, and monitor. So we need to think of the software supply chain as similar to any other supply chain. It's a set of processes that help build a product at its most, basic level. We also want to keep in mind, if you're thinking in terms of CI/CD, continuous integration or continuous deliver or deploy, that's really the heart of what the development team is going to focus on, but there are activities outside of that in terms of planning and operations itself. So what is a container supply chain? Now that we've had the refresher on your basic software supply chain, where does the container supply chain fit in? Well, I like to really, when you really talk about pipelines and supply chains, they're kind of interchangeable. I like to think of software pipelines as a pipeline of pipelines, because it's really, you have these sub pipelines that link to them and that are, below them. And container supply chain is one of those things. So you're going to have your software supply chain, your software pipeline, where you build and test your app. You're going to do your unit and functional testing there generally. Then you create your WAR file as an example, and then you're going to layer that into a container. And this is where you'll see on the right, you'll see the container pipeline. And then you're going to do your container specific testing generally, and then you'll publish it to a repository or registry. And FYI, I know people tend to use those terms interchangeably. The repository to confirm is specific to your project, and the registry is something that holds multiple repositories. I know that always is a little, it's a little thing for me that I get very annoyed about when people interchangeably use those terms. So let's talk a little bit about supply chain threats. This is from the SAST Security Framework project, one of my new favorite projects out there because it focuses on software supply chain threats, and it breaks it down into maturity levels and how you can address those threats in your own software supply chain. So let's talk through some of them. You bypassed code review. If you have code pairing or manual code review, that's an element where if you don't do it, then there's that's a threat to your software supply chain. You could have a compromised source control system. That's a common attack vector where you could actually attack the entire registry, the repository, individually. You could do typo squatting. That's a way you compromise the source control system. Modified code after source control, where you're not strictly doing your revision control in conjunction through your source control system. You could have a compromised build platform, whatever your CI/CD system is. You could have a bad dependency. One of the components, which we've talked a lot about, a lot this week, right? Using a vulnerable or compromised or a questionable dependency in your product. You could have bypassed CI/CD altogether and just published something from a developer desktop. You could have a compromised package repo, or you could just have a bad package. These are just some of the elements that you should think about that could impact your own supply chain. Let's talk about a little bit about this is the NIST software supply chain risks. And you'll see they've broken it up into the typical software lifecycle of design, development and production, distribution, acquisition and deployment, maintenance, and also disposal. It encompasses also an enterprise idea of the software supply chain as well, in terms of maybe in fact, I've observed that some enterprises, especially finance, has as many or more developers than a software company can, right? And so you have additional concepts and additional concerns that you need to be aware of in terms of sensitive data spillage, right? But I think we're all aware of some of these, design phase. For example, they provide examples from NIST. Hijacked cellular devices, which was a hardware attack. We all know about the SolarWinds compromise, end user device malware, because you're involved, of course, in the interaction with software. You have banned vendors, as we see here, and backdoors embedded in. You could have that in components or through routine maintenance updates. I think this will be in my references, but I recommend the NIST Defending Against Software Supply Chain Attacks document. It's excellent. So let's just talk again about software supply chain security. What does that really mean? It means adding assurance to the software development process. You're creating confidence and trust in the source material and the practices that you use. It's basically a holistic view for protecting each phase of your software development lifecycle. And you're approaching the SDLC as a set of business processes. And you're going to get sick of hearing me say that, because I really believe that's what it is. If you really want to understand your supply chain, you have to look at and document in a very detailed way and examine and threat model your business rules for creating product, like software product, essentially. And you're validating the final product meets a reasonable set of security criteria to ensure that it's not vulnerable. This is not new. There have been attacks like this for a long time. One that comes to mind is there was a well-known token attack, a security token attack, and everyone had to replace tokens. This was about 10 years ago, but I think it's out of sight, out of mind. For some reason now it's become very prominent. There's heightened attention, and a lot of governments and large private sector organizations are now becoming increasingly concerned about this. So let's exit the supply chain for a second. Now we're going to talk specifically about a container. What is a container? Just a bunch of software ingredients, in my opinion. This is from Docker, and I think everybody knows about Docker. It's sort of become interchangeable with the idea of a container, in the same way that you have, everybody says Xerox for a photocopy, or Kleenex for a tissue, but we really know it's not the same thing. It's just a brand. And that's Docker really helped advance the usage and the practices surrounding containerization. And they define it as a standard unit of software that packages up code. Pretty simple. It's a lightweight standalone executable package. It's portable, it's modular. It makes the delivery of applications much easier. Essentially, that's the shift, that's the evolution that radically changed what we know of application delivery over the last 5 years. I mean, it's just been phenomenal from my perspective. Okay, so let's talk about virtual machines versus containers. I think this is really important because a lot of people seem to think that they're the same thing, and they definitively are not. And I'm going to point out the important bit that you need to, that's the takeaway for you in terms of security. So on the left, you'll see a typical, this is, and by the way, this is from Docker's site. This is your typical hypervisor and guest architecture, right? You have your bare metal system, you have a hypervisor that's installed, and then you have it, and I'm not going to go into confidential computing or anything related to that, but so this is very general and high level. This is, you have your virtual machines with their guest operating systems, and then on the right, you have containerized applications. And I think the key thing to remember here, if you look at the left and you look at the right, the guests in a virtual machine have their own operating system. On the right, it's a shared operating system and kernel. This is really important to remember. A container runtime is responsible for running a container and other associated tasks as downloading or unpacking the image, but it does not rely on its own, like every container does not have a separate kernel. It's shared memory, shared kernel. Essentially, that's what you need to understand. You do have segmentation options that you can employ, but at the end of the day, it's shared kernel. Okay. So we talked about the shared kernel. So user space versus kernel space. This is a really key idea. We used to have these conversations all the time in the Unix land, right? Back in the day. I'm dating myself, right? But again, as I mentioned, virtual machines run their own isolated kernels. There's no shared memory or execution space between these guests, which run applications, right? When we used to have multi-user shell systems, this discussion came up a lot, right? People on the call may remember things like chrooted jail cells, right? Which were kind of like a proto containerization technique, right? And I think this is important to remember because without the addition of a virtual machine technology, like you have Kata, Firecracker, or gvisor, those are all, you may know of those as containerization technologies. Without the addition of those techniques, containers share the same host kernel. Now, you do have things like Linux namespaces capabilities, seccomp, SC Linux, AppArmor, C groups. It's, I know, overwhelming. You can use these techniques to enhance segmentation between running container instances on the host, but again, shared kernel. Okay, now the fun bit, maybe. Here's what you need to understand about what the composition of a container, right? I have the cake on the right because you need to think about it in terms of a layer cake, right? You start at the top generally, maybe on the side. Okay, but most people start on the top, I think. And it's good for my analogy, so I'm going to use it. So you start at the top and you go down through the cake, right? And it's kind of how it works here. Images are file system bundles built of layers. This is how OCI compliant images work. and it's a union file system, and it has the following properties. It's a logical merge. It's an overlay file system, right? You have read-only lower layers and a writable upper layer. And again, like the cake analogy, you begin reading from the upper layer first. It's copy on write. I think the layering understanding will be important as I hit some of the other topics related to hardening, but it's really important that you understand that layer concept. Okay, this is the really interesting, fun bit. I know I keep saying that, but it's true. Everybody talks about Docker, right? As I mentioned before, right? They really did a great thing in popularizing containerization, but really Docker is it's a container management, a high-level container management system, right? You actually don't need Docker. You don't need Docker to run containers. So it's what we also refer to. You can sometimes call Docker a container runtime interface, but not so much anymore because they donated container D to the CNCF. So now you really refer to Docker. You put it in the same category as Podman as a high-level container management system. Then you have high-level container runtimes, which are things like Cryo, which is specific to Red Hat and OpenShift. You have Container D, which is what we more often see. I still have Docker in here. This isn't my diagram, of course. I have the link below, but you can still run Docker as a high-level container runtime, but that Kubernetes, for example, that is no longer the default. These are all, of course, using the OCI standard. And then you have low-level container runtimes. This is important. Run C. For example, the reason why this is important, there was a couple of years ago, there was a really obnoxious Run C vulnerability. And depending, it was indifferent to whatever high-level container runtime you used or high-level container management that you used. But depending on what high-level container runtime you used, if it was, which at the heart, a lot of them were using Run C. So if you had that vulnerability, you had to walk it back to figure out how you were going to update that, right? You do have, I have Kata Runtime and gvisor on there because they're a little unique and they have VM technology integrated or some sandboxing technology integrated. I know. You're overwhelmed. Take a deep breath. Okay. It's confusing, but I do have references in the material which will help you and you can follow up on it. And hopefully that will give you some better clarity later on. So container misconceptions. The container is a full virtual machine or an AMI. It's not what it is. That you can and should put your entire monolithic application stack into a container. Please do not do that. It's a bad idea. I will tell you why later. That the container is the same as the running instance. Okay, it's a pet peeve of mine. I really prefer to be very specific regarding, and you will hear me say frequently container image, container instance. And I do that because there's a lot of discussion and it turns into a philosophical war over which is which. But what you need to know is that these are two different things, that the image is not the same as the instance. It will be instantiated generally as the instance, but in terms of security visibility, it's very important to understand the difference. And again, a container is just a software package, including its dependencies, libraries, application runtime that will run in a dedicated area of user space. Okay, this is why the security of the supply chain is critical. Okay, where do you get your container? So a typical recipe, and I hope everybody's noticing that I'm using the food metaphors here and analogies. I spent a lot of time to find pictures that helped with that. So your typical recipes for container images. You can pull a base image from a public or private registry, add your code and configuration. There you go. I just hit the layers. That's why your understanding of layers is important, right? You can use a multi-stage build. You selectively copy what you need in the image without using a base or parent image at all. You can build, if you feel like it, you can build the entire OCI compliant image yourself using a tool like Builda, which is open source, right? You can create something, this is my favorite. You can create a single layer image. It's called a from scratch image. It's a no-op using a statically compiled binary. That's just my favorite because I'm a security person, right? You can also make a distroless image that only includes the application and runtime dependencies. My second favorite. Okay, use the best ingredients. That's the recommendation, right? You want to, if you do use an external source for base images, you want to use a trusted source. Okay, there are various ways you can guarantee that, but I think an important point here is to understand that you're still going to validate those. Typically, if you bring something in from the outside, the recommendation is that you want to validate it. You want to, I worked in one place where we had what we called a quarantine process. So it's preferable, while not always possible, it's preferable to generate as much of the material for a container internally so that you can really trust your image, right? Especially a base image. So you want to, again, you want to validate the image with a container security tool or a software composition analysis tool, which focuses on your dependencies and components, and also your licensing, of course. But you want to use that to identify either one of those or both. Sometimes people use both to identify vulnerabilities. You want to economize. As I mentioned when I was talking about using the best ingredients, right, and where you get your container from, you want to only add elements necessary for your microservice. Remember how I said that you don't want to put your entire monolithic stack in your container? Well, you want it to be economical. Why? Because the bigger your container, the bigger the attack surface, the more difficult it is to harden, honestly. You want to reduce, you want to follow least privilege. You don't want to run root processes. You don't want to run the container as privileged. FYI, if you didn't already know this, running a container as privileged it's pretty much game over. It's probably one of the worst things you can do. In fact, as a security person, when I'm doing my own, when I'm doing a capture the flag or something, if I see something running as privileged, it's like, yay, I win. So don't do that. You want to limit syscalls if you can. I recognize that this can be challenging, but it's a lot of bang for the buck. You want to parameterize. Don't hard code configs or embed credentials or secrets in the image. Parameterize. You don't want to have a shell in your container. It's all about immutability. You shouldn't be logging into a running instance. You want to minimize you want to use techniques like distroless or from scratch to minimize and eliminate unnecessary elements and layers, and automation. If it's really beneficial to automate your containerization deployment, because it automatically, you have the ability to use separation of duties and least privileged through your automation system. It's great. So fry, bake, and buy. Let's talk about those concepts. You may have heard of this from in cloud native land. This is bootstrapping, baking versus bootstrapping, for example, when you're deploying images to the cloud. So frying is the concept of building or extending third-party images deployed but changed during bootstrapping activity, which means bootstrapping activity is at instantiation time, when the container goes from the image to the running instance, right? You can't attest that because it's changed as it's being instantiated. Baking, which is custom built or extended third-party images, fully created with all the dependencies as part of a supply chain. You can attest and you can verify that this is immutable. Or you can just buy, which means when I say buy, you can just use a third-party or vendor image deployed without changes. attested and immutable. Okay, the message here, bake or buy, never fry. Okay, here is a basic container security validation process. You'll see I've broken it up into 1A and 1B. 1A is third-party images that you're not changing. That's sort of the buy. You may fork these, with your own custom stuff in terms of baking it. 1B is purely internally built. You'll see here, item 2 is you're performing a container security validation on the image. You're checking for vulnerabilities, hardening. You may do outside the pipeline, you actually may have a regular scanning of your repository and registry in addition to that. Let's say, and the reasoning behind that is that, let's say you're not regularly rebuilding your container images. That's a good use case for why you might be scanning outside the pipeline, right? So your typical validation criteria, as I've written below, is okay. You may want to say that anything with a CVSS score greater than or equal to 7 can't be instantiated at runtime, or you may check to see if there are root-owned processes in the image. You want to make sure that the image isn't going to try to run as privileged. You may want to check to see if a shell is installed. You could also do licensing checks here as well, depending on the container security tooling that you use. And stage 3 is the container is deployed to a runtime environment from a repository through a pipeline. And you have a runtime control component that ensures that only security validated signed images are deployed and can run. Spoiler alert, you can do this with something called admission control on Kubernetes. Here we go, container orchestrators. So you could use a tool like Docker and you could just use LXC and you could just run a container on a host. That's not very sustainable. It's not very scalable. So typically what people use are orchestrators such as what everybody's heard of, Kubernetes, right? So you have an orchestrator that handles the deployment and runtime lifecycle of a running instance. It can scale instances up and down to meet demand, offers redundancy and availability options for running instances and hosts. You have load balancing, service discovery, health monitoring. Some people like to think of it as an abstraction layer on top of, say, something that you may already be using, like VMware or a public cloud, right? It can be it's very developer friendly for that reason, because then they have the direct accessibility to the container orchestration system. It can also provide a level of multi-tenancy through network segmentation and resource restrictions. And you're very familiar probably with Kubernetes, but you also have OpenShift, which is a specific version of Kubernetes. You also have Mesos and Nomad, for example. You also have cloud provider managed orchestrators like EKS, GKE, AKS. The wonderful thing about a container orchestrator, for example, like Kubernetes, is that you have policies with an entry point that ensures that only instances that pass are allowed to run. This is something, as I mentioned, called admission control. I like to think of this as an orchestrator providing a last gate for a container prior to runtime. Again, with Kubernetes, there are various policy mechanisms. I think that's one of the winning points, the winning aspect of Kubernetes for that reason. I just want to point out the CNCF actually came out with a really great white paper on the principles of supply chain security. And this is excellent. I recommend that you look it up and that you spend some time with this. The CNCF is the Cloud Native Compute Foundation, and their area of focus is on cloud native technologies such as Kubernetes, containerization, the 12-factor app. And the important thing, the difficulty with cloud native technologies is that it's the high level of automation, this high level of ephemerality, the concept of immutability, and this just-in-time delivery. So it's really critical to include trust, validation, assurance, attestation, every state change, every phase of the supply chain. So you're talking about establishing and verifying trust at every step in the process, as they're mentioning here, frequently through cryptographic validation. For example, you do have the ability to sign containers, and I recommend that you look into that, investigate that, and employ that. It's a good technique to use. Automate everything that you possibly can, right? It prevents error. Well, it reduces it in a lot of ways. And then you also automatically can integrate concepts of separation of duties and least privilege through automation tools. You want to provide clarity. Every step in the software build and supply chain process should be clearly defined with a precise limited scope. Remember how I mentioned that this is about business rules and you want to heavily document your supply chain? I frequently get pushback from people who say, but it's self-documenting. No, it's not. It's not. And I think that supply chains, you should over-document. You should err on the side of over-documentation. You want to document every actor, every touch point in the supply chain, whether it's human or machine, and you want to make sure it has a clearly defined role. And again, separation of duties and least privilege. And you want this concept of mutual authentication. This is very important in modern cloud native technologies, because as you decompose, you need to make sure that as they talk to each other again, that now trust but verify. So I'm mindful of the time. I want to give everybody some chances for questions. So I'm not going to read too much of this, but I encourage you to look into NIST SP 800-190. It's the Application Container Security Guide. It talks about the tiers of container technology architecture. This is very high level and abstract, but it's great if you're a security and compliance person or you're in a leadership role. It kind of pulls up a little bit and goes into detail about the phases of the container supply chain and the demarc points in the container technology architecture that are important for you to understand. They break it down into the 3 high-level phases, which are image creation, testing and accreditation, image storage and retrieval, and then container deployment and management. Slightly different from what I've done, but still really, really helpful. Sbombs. Don't we all love Sbombs? We've been talking about these for a long time. And now, because of certain things that have recently occurred and executive orders in the US, now Sbombs are actually required by the federal government here, and also a lot of the financial community is requiring this as well. An SBOM is, again, a software bill of materials. It's a formal list of your software ingredients, including open source components and licenses. Again, as I mentioned, this is now becoming required, and it's getting a lot of attention due to recent software supply chain attacks, and Executive Order 14028 defined like very specific software supply chain security criteria for federal information systems. This specifically included providing an SBOM to the purchaser for each product or publishing it on a website. And you can generate an SBOM. So you're probably thinking, no, that's somebody else's job. FYI, there are tools to let you, open source software tools that let you generate an SBOM for your container as well. Sift and Turn are 2 of them, but this is probably going to be baked in. This capability will be baked into commercial tools as well, I'm sure, at some point. Okay, here is a real world use case of an actual container kitchen, as I call it, or a container lifecycle. And I'm going to walk you through it a little bit. I have the time to do that. So far left, let's start there. The developer pushes the code, which then triggers a build to the CI/CD system for the container lifecycle. And you'll see on the top, I have policy validation service, and at the bottom, I have image security validation service. A place where I worked, where we did this, we had policies beyond just security policies. Maybe you have, I don't know, residency requirements, or you want to check for certain issues, maybe you want to check licensing and that's not part of your security validation, or you don't want to use certain tools or certain versions of something, or you want to check for your versioning of the container to make sure that you're following a semantic versioning standard used by your organization. Again, I'm just throwing out some examples of why you might want to perform some type of policy validation with a system like Open Policy Agent. I think Kyverno is another one, in addition to your security validation, right? Then there's a publishing phase to this, where you publish it in a core container image registry, right? Because here's what is a good recommendation: that you have production and you have non-production, and you want your non-prod environment to be a mirror of your production environment, right? You want it to be the same. And so you start with your distribution to your non-prod environment, and it's going to be, you see how it's almost exactly the same. And then this is where release management comes in. I am a strong believer in release management for security use cases and for validating that it's good to go, check. And so once you've passed release, you have certain testing that occurs here. You're submitting testing evidence. FYI, this is super important in government and in finance, right? Then, only then do you promote or distribute to production. And you'll notice that there are multiple places here where you're validating, right? You're signing as part of your distribution. You're validating at multiple places. And one thing that I want to talk about is that this is a key element for me, DevSecOps decisioning principles. A lot of people say they do DevSecOps, but what they do is they overwhelm people with information, right? At its best, security tools should integrate as decision points in a pipeline. And as you'll see here, these are all decision points. Like at any point, it will stop if it doesn't meet the decision. Now, the decisions are different, but your DevSecOps tools should have a policy engine that can respond with pass-fail decisions in your pipeline. And the criteria is going to vary, right? So this optimizes your response time. It supports separation of duties, as I've mentioned before. You have fast and frugal decisioning. You can have contextual risk scoring at your release management phase. This is a very elegant but complicated concept to really implement in practice. But I think this is the next level of where you need to be in terms of container deployment and your software supply chain. So I'm not going to go into too much detail about this. I actually have a reference for some material that goes into detail about this a little more. But I think what you need to take away here is you need to be looking for and identifying your opportunities, shall we say, for decisioning, for security and policy decisioning, every state change in this life cycle, because that's what you need to focus on. Where are the state changes? That's my opportunity to validate. Okay, reminders, we're almost at the end. We're circling. We're at the end here. Okay, small is beautiful. Make your images compact, leaving out unnecessary libraries and binaries you don't need. Who do you trust? What are your trusted registries? Are they internal or certain external ones? Who are they and that supply your base images? You need to identify that. Validate, validate, validate. They should be free. Your images should be free of vulnerable libraries and components, or as much as possible, right? Container images should not need to run as privileged or have processes that run as root. Don't put credentials, keys, or tokens in your image. Reduce your listening ports needed in your container image. It just increases your attack surface and the resources that need to be secured. Make sure to use a standard runtime. I know this seems obvious, but container security tools aren't tested with every runtime. Like if you go off and you decide to use Kata, you might freak out your security team. They're like, wow, we don't know how that's going to work with our security tool. A container isn't a host. It's an ephemeral drop of rain. You shouldn't be logging in and trying to change it because it's going to evaporate. Again, only attested immutable container images should run in your environment. Do not log into containers, please. Automate, automate, automate your container builds and deploys, and constantly reevaluate your supply chain. Verify your source code, verify dependencies, sign and protect pipelines and artifacts. Because remember, your container is just the bundle of the stuff that was to the left of it, right? Which is your code. Okay, I have, and I will post these somehow, a lot of references. I think that's the most reference slides I've ever had for any presentation I've ever done. Thank you for, you guys, everybody was super patient. I know this was very nerdy and I appreciate your time. And now I think it's time for questions, if we actually have time.
Yeah, we have a few minutes. So first of all, thank you for sharing that excellent presentation. Lots of, as you said, very nerdy details. And I think for the SAP community in particular, our customer and partner community, we're on this verge of, moving from on-premise to cloud and beginning to adopt containers as part of that. And this is great primer and early study material for many of the people beginning to make those kinds of jumps. Could you go back a second to the reminder slide?
Oh, certainly. Let me just walk through these references.
Yeah.
Oh, wait.
Those are a lot. Yeah, there.
Yeah.
I think this is a great list for developers because a lot of this impacts us during the development lifecycle. And the couple that really resonated to me as a developer, it was the keeping your dependencies down, keeping your size down. It's so easy. I do a lot of Node.js development. It's so easy to throw a package in there during development time, test it out. It didn't do what I wanted, but you leave it in your package JSON, and then that thing lives in there forever. It is so easy to not stay lean, and then before you know it, you've got all these dependencies, and you're like, well, was I using that? I can't remember where that came in.
Then you have a jerk like me come in, like, why is that in there? Oh, by the way, that's vulnerable. And you're like, oh, what'd I do?
Yeah, but that is so easy as a developer to throw things in during development time, and then they just live there forever. But I think that's a really great one. And the other one that resonated for me was the listing ports. As developers, we're really bad about wildcarding ports, right? Because we don't want to. We're going to debug later, So let's just make them all open and stuff like that. But in the container world, that is so important to narrow that. I mean, you're used to, I'm testing on my local machine. I don't care which ports are open and whatnot. And when you really move that into the cloud and have that as an attack surface, that's so important.
I have had these conversations. I mean, I literally have had all these conversations multiple times, and it's not, it's a new medium, and I think that's why it's important to have these conversations. These should be dialogues, right? And I think what helps me help people here is that I came from a Unix. I built application stack systems. I was a network engineer. So I think that kind of helps, right?
Yeah. So while we were discussing those points, we did get a couple questions in. One, I want to back up. There while you were presenting, there was a section where we were talking about the difference between Docker images and Docker instances, and
Right.
I think I answered. I mean, I answered it in the flow what we're going, but one of the attendees was asking, would a good analogy be there? Remember, this is all primarily application developers watching here. They want to know, was that like having a class and then an instance of the class, an object instance in a programming? And I said, well, yeah, that's a pretty good analogy, I think. Because one is the definition of what you want, and the other is the living runtime version of that, right?
Kind of. I mean, okay, but so you need to think of, in your mind, you need to stitch together the package, which is the container, the image, and runtime. You will literally have, when your container it's instantiated and it's running. It's a running container instance, and it's it's still a segregated or segmented instance of your stuff at runtime, but it's the expression of it. It's like the difference if you were to take, when you take your binary, right? So you have an executable binary, but it's not really executing until you run it, right? Mm-hmm. And that's really what the difference is. And the reason why it's so important to differentiate is there are a lot of things that change at runtime that you can change and shouldn't, obviously. But when you're in Docker and you're interacting with, like, if you're just doing development, you're interacting with it. Like, it's a very different thing when you're in Docker interacting with the image versus the running container. And that's also important in Kubernetes, in your orchestration system. So it's also very difficult, FYI, if you're in security on this call, to try to stitch together the container image and the instance, that can be very challenging. I would rather actually sort of look at it. Maybe this is my cloud bias here. The infrastructure as code, like the Terraform template, the CloudFormation code versus the actual resources that you've deployed into, you can change. I can go change that security group through the AWS console, right? Sure. Mm-hmm. But if the infrastructure as code still has the bad security group, every time they run the pipeline, it just comes back. I've had this conversation in the real world. It's like, why does that keep coming back? Oh, it's the infrastructure as code.
Yeah. I mean, at first glance, the fact that in Kubernetes or Docker or whatever, that you can shell into the running container instance feels very cool and exciting, and a great way to debug, but it's almost always a red flag. The fact that you had to shell into that is, or if you do anything in that shell session, that's probably a sign of trouble down the road.
Yeah, if you want to play, FYI, if you want to play with Kubernetes, the best thing you can do for yourself is download and use MiniCube or MiniShift, which are local versions. Like, that's a version of Kubernetes or OpenShift that you can install very quickly on your local desktop. Mm-hmm. Make sure your security person is okay with it before you do that. I'm not telling you to do it, but it's an environment where you could test and interact with Kubernetes. And FYI, if you think you need to troubleshoot, or somebody tells you they need to troubleshoot by logging in to the container in Kubernetes, you don't have to do that. There's a debug option that actually replicates it and will allow you to debug not on the production running instance. So I'm a big fan of OC debug, or the Kubernetes implementation of debug.
And just to also kind of put that maybe into the SAP specific context there, we also offer an installation of Kima that will run on MiniCube as well. So if you want to get a Kubernetes environment with also some of the SAP provided functionality there in the form of Kima, you can run that on MiniCube. We even have some videos on this very YouTube channel of how to set up that on your local desktop and get started doing Kubernetes development with Kima on MiniCube.
Good for us. That's great.
Yeah. All right. I have another question here, and it has to do with zero-day vulnerabilities in this kind of architecture. So you said, so what are the protocols in case of a 0 day? In particular, will it be patched as a hot fix? But then how does that propagate into the rest of the architecture in this scenario?
Yeah, so I have very specific feelings about this. Okay, so I'm assuming that as a good environment, you're using a container runtime security tool. I frequently recommend that you use the same tool for image assurance and at runtime, because it stitches the image together with the runtime, the instantiated instance, right? Makes it a little easier. So let's say your runtime tool identifies like a vulnerability, right? That just came in. So you can't, the great thing about some of the newer container security tools, they have an admission control element. So say if somebody is actually trying to instantiate the image, and it's a newer vulnerability, it can catch it there at deployment. But then there are some tools that will actually have enforcement mechanisms or alerting mechanisms. So something comes in, it observes it, it can send out an alert to your SIM or your security operations center. It can also enforce. You have options in Kubernetes. There's something called eviction and draining. Proceed with caution, but you do have these tools that can do that. And then once you have that alerting, once you have maybe that enforcement that maybe will shut down that container, if your application will tolerate that, like if you're a bank, proceed with caution, right? But let's say that you have that enforcement mechanism in place. Now, the next step is to reinstantiate, right? To rebuild, is to go through your rebuild lifecycle. I will never recommend patching a container, a running container. I think that's the worst thing you can possibly do, not just in terms of security, which is questionable, but from your development lifecycle. It's, from a cloud native perspective, that running system is supposed to be immutable. So the right way to fix something is to redeploy. That's what your pipeline is for. Use it. It's great. Automated pipelines are awesome. So that's my recommendation.
Very nice. Very good. Well, that's all the questions that we have so far this morning. And we are nearly to the top of the hour anyway, so it's just about time to wrap up here. Once again, I want to thank you, Michelle, for coming on and sharing your wisdom on this topic with the developer community here. I'm sure everyone appreciates the insights and explanations that you've provided to us today. So thank you once again.
No, thank you, Thomas. I really appreciate being here, and the developer community is my favorite community.
And with that, this was the last session, educational session for Security Week of Devtoberfest Week 4. Keep in mind that we still have the coding challenge for this week, which we discussed in yesterday's session. And you have until next Wednesday to complete the coding challenge, either the ABAP or the Cloud Application Programming Model Node.js coding challenge, or tackle both of them if you want. And a reminder that tomorrow we're going to do our Fun Friday gaming. So join the Discord server and game online with some of your fellow SAP community members. And then, of course, next week is week 5, and we'll kick off the week on Monday with our first data and analytics session. So the topic for next week is all data and analytics. So big data, HANA, data warehouse, SAP Analytics Cloud. These are all things that you're going to hear about in next week's sessions. So I want to thank everybody for joining all the security sessions this week for Devtoberfest, and we'll see you again next week for data and analytics. Until then, have a good day, everyone.